Many programmers are aware of two dialects of x86 assembly, the official Intel syntax and the AT&T syntax. The most prominent differences between them are the ordering of the operands and the syntax for encoding effective addresses. AT&T syntax is also distinctive for its use of percent signs and dollar signs to identify registers and constants. If you've been watching this channel, you know which syntax I prefer. And you haven't been shy about sharing your own opinions about which syntax is better. Why did AT&T invent their own syntax anyway? And why do some people say you haven't truly experienced x86 until you've assembled it in the original Klingon? Let's start with the AT&T syntax. In the 1970s, AT&T's Bell Labs developed the Unix operating system to run on computers like the Digital Equipment Corporation's PDP-11. In 1978, they ported the OS to a new CPU released that year called the 8086. The 8086 microprocessor was created by Intel, then only a 10-year-old company many years away from becoming Chipzilla. It was a lot smaller than AT&T or Digital at the time. AT&T, known as Ma Bell, was a century-old giant company. The government was trying to break them up. They were pretty much the evil empire. In only a couple of years, they changed their logo to be the Death Star. The 8086 was similar to the PDP-11 in a lot of ways. Both chips were 16-bit CISC designs and instructions could operate on registers or memory. Here's some PDP-11 assembler from the original Unix source code. There's a lot of familiar syntax here if you're a AT&T syntax programmer. Lots of these PDP-11 instructions translate pretty cleanly into equivalent 8086 instructions, although some of the PDP-11 features like auto increment and decrement only apply in special cases on 8086. The story goes that rather than using the Intel syntax, the Bell Labs folks just modified their existing assembler with minimal parser changes. After all, why take the trouble to deal with some startup syntax when you're the evil empire? At least that's the story. I haven't found any primary sources that confirm the origin of the syntax. The best I found was a paper that states that Bell Labs had a portable assembler, but it doesn't talk about the syntax. I think it's interesting how so many people argue about whether it's more natural for the destination operand to come first or second. But is anybody talking about where the mnemonic should go? Why does it have to come before the operands? In most programming languages, we put the operator in the middle. It's like the verb in the sentence. And the source operand could be the subject and the destination could be the object. Why don't we write assembly like that? Writing it in English looks kind of awkward, even if you reword it, in my opinion. But the reordered assembly looks kind of reasonable to me. It's like the Intel syntax, but with the operator in the middle, and it has the same word order as the high-level code. This object-verb-subject-word order that we use in our programming is grammatically very rare in language. Wikipedia lists only 3 terrestrial languages with less than 20,000 native speakers. But there's a notable extraterrestrial language that uses this word order, Klingon. The Klingon language was designed by Mark Okrand, who set out to make an alien language for Paramount Pictures to use in Star Trek movies. There's an official dictionary, and even a translation of Hamlet, link in the description of course. He chose the object-verb-subject-word order because it's so unusual in human speech and writing. But I think it's actually a pretty natural word order for programming. Klingon x86 assembly might look something like this, except this is just reordered Intel syntax rendered in this awesome font. It's not using any Klingon vocabulary. The Klingon language uses lots of prefixes and suffixes, which should presumably carry into their assembler dialect a la the AT&T syntax. I'm obviously in over my head here. This sounds like a problem for AI. So I tried using Bing Translate to get a more accurate translation, and it happily generates some Latinized Klingon that looks legit at first glance. But unfortunately, it's not very good. When translating it back to English, I got garbage. I also tried ChatGPT. This certainly looks more like code than what Bing gives me. It's interesting how it takes instructions and splits them into two parts, but I guess that's because it's trying to explain the code, not actually translate it. Round tripping back to Intel syntax, ChatGPT does generate mostly kind of valid assembly code, although it's not quite what I started with. Twice as many instructions, and it's full of bugs. It would seem if there ever was an original Klingon syntax, it's been lost. Perhaps AT&T annihilated it with their Death Star back in the 1980s. So what we have is the Intel syntax and the AT&T syntax. And as you know, I prefer the AT&T. The primary reason to love the AT&T syntax is that you get access to the obscure RIS register, which I discussed in my NOT video. This pseudo register tells the assembler to emit an SIB byte, but without an index register, which could be useful if you need to control the length of an emitted instruction. Another reason to embrace the AT&T syntax is that there's so much open source code written in it, with comments and Git history. It's the best syntax for learning and contributing. Besides, if you code in Linux, all the tools default to AT&T syntax. Go with the flow. Don't spend your career typing -m Intel or editing your conf files. Now, if you're a Windows programmer or an Intel employee, then I won't fault you for using the Intel syntax, even if your RIS levels are affected. On the topic of learning, that earlier PDP-11 code listing is an excerpt from Lyon's Commentary on Unix, a classic dating back to 1976. It was officially only available to Unix licensees, but bootleg photocopies circulated widely. It's legally in print again. There's 9,000 lines of Unix kernel source in C and PDP-11 assembly. That's not a lot of code. If you put in the time, you can actually read it all and understand how a Unix kernel actually works, including the scheduler, file system, and boot process. The source is accompanied by John Lyon's well-written commentary, which explains how everything works. I wish I'd known about this book 20 years ago. It's amazing how relevant it is still today, and it's cool to see the origins of all the system calls, signals, devices, and other Unix concepts. I've put a link in the description. Full disclosure, I could earn a commission.